You probably clicked on this video thinking that I'd reveal the secret to landing internships or creating a successful startup. Well, unfortunately, I'm looking for that too. But don't click off the video yet, because I'm going to be sharing my take on the one question that you need to answer before becoming an engineer. For context, my name is Yang Yang and I'm a first-year engineering science student here at the University of Toronto. I'm currently taking a course called Praxis, which is all about refining your skills in engineering design. But what does that mean? I present to you the million-dollar question. What is engineering design? The definition of engineering is the application of science to the optimum conversion of natural resources to human uses. I mean, that sounds like a bunch of yap, but to me that means applying the things that you learned in math and science to build really cool things like bridges, buildings, solar panels, and spaceships. When you think of engineers, you often think of the technology that they invent, like the device you're watching on right now. Design is different though. When I think of design, I think of art, like Bob Ross or whatever this is. Design includes making decisions with purpose, but there's no limitations to design. No math, no science. You might choose a different color or shade just because you feel like it. However, when you combine engineering and design, you get a beautiful intersection where there are some rules, but you can create anything. The way that I approach engineering design is very intuitive, where I like to build things off of what I know and what I can imagine, taking things that already exist, otherwise known as reference designs, and using them to brainstorm ideas and checking the math afterwards. I found that oftentimes when you approach a problem solely mathematically or scientifically, the answer is right, but it's not the right answer. Whereas thinking intuitively brings answers that math can't always explain. For example, in my civil engineering course, Civ 102, we were given a project where we had limited materials and we were tasked to design a bridge to hold the most weight possible. My group did a lot of calculations in MATLAB and Python to find the most optimal way to build our bridge. However, in the end, we chose a design that wasn't the most optimal one. We knew that the stronger designs required more glue to build, a resource that we had limited supply of. They were also a lot more complicated to build, so we chose a design that was simple yet strong, leaving a lot less room for human error. Our bridge was able to hold 740 newtons, placing us third overall out of over 250 students. At a recent conference I attended, a speaker named Tristan Ladlow, who works at Boston Dynamics, talked about something that I think really reflects the way I approach engineering design. This being the sim-to-real gap, a phenomenon that occurs when reinforced learning simulations find loopholes in the simulation that allows them to complete tasks in ways that wouldn't be possible in real life. This goes to show that the mathematical and scientific approach isn't always complete without using intuition to consider the practicality in real life. Using intuition also means using your past experiences, your successes, and your failures to make decisions. In my civil engineering class, we learned that to find a solution, you often need to know the answer already. Now, this doesn't really make any sense at face value, but what it means to me is that you need to have seen a similar solution somewhere else to help you build that intuition, which will help you solve the current problem at hand. If you want to see more videos like this one, make sure to subscribe to my channel. I hope this video was helpful and got you thinking about what engineering design means to you.